All right, welcome grade 9s. Today's lesson is measures of spread. Basically, we want to see how the data is spread out. And one of the measures of the spread is the range. And the other one is the IQR, or the interquartile range. Okay. And the third one we're going to do is look at a visual representation of how the data is spread. Okay, so that is how we're going to look at box plots, or they also call box-and-whisker plots. And then we are going to look at how the data is spread. Okay, so box plots or box-and-whisker plots. Okay, so that's what we're going to do in today's lesson. Now, to begin with, we're going to compare two players, right? Player A and player B. And let's say we want to look at how these two players are similar or different statistically. In the first case, both players have the same median score. As you can see, there are nine games they've played, and both players have, or it might be both teams, both players have a median of 6. And if you add all the data values and divide by 9, for player A, you will get a mean score of 6. And the same thing for player B. If you add all the data values, 4 plus 4 plus 5 plus 6 plus 6 plus 7 plus 7 plus 7 plus 8, okay? And that will be 54. And then you divide it by 9, because there are 9 data values, you should still get a value of 6, okay? So this was done in the last class, finding the mean value. Okay, so both have the same median and the same mean of 6. Now, how are you going to compare both the players? Okay, or how would you compare two teams? In this case, you also want to look at how the data is spread. Okay, we want to see who is more consistent. So in the first player A, you can see the minimum is at 1, the maximum is at 9. And for player B, the minimum is 4 and the maximum is 8. It looks like the data are closer together for player B. It appears that player B has data that's more consistent and close together. Okay, player A, on the other hand, has some very good days and some very not so good days, right? So so that might be an interpretation about both the players. You can always draw inferences, and some of these inferences are just based on a few data points. Okay, to make solid inferences, you need more data points. Okay, let's move on. So the range is one of the definitions of the spread in data. Range is the difference between the maximum data value and the minimum data value. In this case, the maximum here is 9 and the minimum is 3. So the range is the maximum value minus the minimum value. So 9 take away 3 is 6. Okay, so that means it just tells you that between the maximum and minimum, the range is, the spread is 6 data values, right? So you have not 6 data values, rather the data is spread by a range of 6. Okay, so between that's the spread between the maximum and the minimum. Okay, moving on. We did this in class, so I'm kind of I've written it all out over here. To find the median, okay, so now we are looking at the green part, right? To find the median, okay, so that's the median. We have to look at how many data values there are. There are 19 values, okay? So from 19 values, we're going to do 19 plus 1 divided by 2. That's how we get the median. 19 plus 1 divided by 2 is the 10th data point. Okay, so if you count here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's where you get the median. Okay, so that's the median. All right, so the median is the middle of the data values. You have to first arrange the data you have to first order it, okay, from lowest to highest. And then you can determine the value of the median. Okay, don't just use it. Don't use this one, right, to find the median value. Okay, you have to organize it. We kind of went through this in class, So I'm rushing through this. And the median, if the median of the first half of the data is the lower quartile. Okay, so that is 5, okay, in this case. And then the median of the second half of the data is the upper quartile, and we call that Q3, and that is 7. The interquartile range, okay, so that's what we're looking at. What is the interquartile range? The interquartile range is Q3 take away Q1, basically the upper quartile, take away the lower quartile. And in this case, that is that is 7 take away 5. Okay, so this is 7, this is 5. So Q3 take away Q1, which is 2. Okay. So that is the quick summary of what we already did in class before we ran out of time. What does the range tell us? The range tells us how the data is spread. Whereas the interquartile range tells us how the middle 50% of the data is spread. Okay, so if you're looking at the middle 50% of the data and want to know how exactly is the middle 50% of the data spread, then we look for the interquartile range. All right. We'll come back when we do box plots, it'll become a little more clearer. For now, just leave that there and we'll do one more example. Okay. The marks on a quiz is shown in the given table. Given table of values, determine the interquartile range. I'm just going to use the abbreviation IQR for interquartile range, okay? So whenever you see IQR, that just means interquartile range, right? So the given table is, there's a table that's given, right? Sorry, I'm just going to erase that. And this value here is 3, okay? Just so you know. That's a typo, that should be 3, okay? Right, so we want to find the interquartile range. So clearly we want to first list out the numbers. There's 1, 2, there's 1, 3. There are 3 4s, 1, 2, 3. There are 5 5s, 1, 2, 3, 4, 5. There are 4 6s, 1, 2, 3, 4. Only 1 7, 3 8s, and 2 9s. Okay, the middle of the data set. Okay, so there are 20, so 20 plus 1. Okay, so that is 20 plus 1, 21 divided by 2. So that is 11.11 and 12. So 11.5, right? Sorry, 10.5, 10.5th data. So basically 10th and 11th data. Okay, so the average of the 10th and 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the median. Okay, so for that, we're going to use the median, all right? So that's, I'm just going to color code this again. I'm going to just put all the medians in green, okay? Bear with me. Right, so that is just going to be 5 plus 6 divided by 2, which is 5.5. I hope I did that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. All right, so that is the median. Okay, so we have the median. Now, to find the interquartile range, in the previous example, we had only one middle value. Now we have 2 middle values, okay? So what should we do with the 5 and 6 in the middle? We have to include it, okay? So when you do that, be careful. Don't drop it. You have to include them because now there are 2 values. You have to include both of them to find the interquartile range, right? So for the first quartile, how many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. Okay, so for the lower quartile. Okay, so that is for the median. Okay, for Q1, we have 10 data values, 10 plus 1 divided by 2. Okay, so that is 11, so 5.5, which is basically between the 5th and the 6th. Okay. So that is 1, 2, 3, 4, 5, and 6. So we're going to take these two, right? So 4 plus 5 divided by 2, 9 divided by 2, which is 4.5, and that is Q1. All right. For Q2, same thing. Okay, so you want to do between the 5th and the 6th here. So 1, 2, 3, 4, 5, 6. So 7 plus 8. Sorry, that's Q3. Pardon me. That is the upper quartile is Q3. So 7 plus 8 divided by 2, and that is 15 divided by 2, which is 7.5. Okay. So again, let me color code this as well, so that it's just kind of, you know, that I'm talking about different things over here. And that is Q3. Okay. So for the interquartile range, or the IQR, so the IQR in this case is 7.5. Take away 4.5, which is 3. Okay, so there's a spread of 3. There's a spread of 3 marks, in this case quiz marks, right? Between middle 50% are all in a spread of 3 marks. Between the highest and the lowest, we know that there's a spread of 7 marks. Okay, so these are just ways to compare stuff. Okay, we'll hopefully we'll do more things that are more meaningful to you, like maybe number of hours spent on a screen time or something like that. We'll look at those kind of examples later. Okay. So now we want to go into the box plot. Okay. So for the median, I think that these are the two values we chose. Okay. So that's the median value. All right. So that's the median was 5.5. And then the first quartile was between 4 and 5. Was that correct? Yeah, between 4 and 5. So that was 4.5. And then the third quartile, right, was between 7 and 8. Okay. And so that is for Q3. This is for Q1. Okay. And this is the median. Okay. So we have, so what we've done is we have taken the 20 data points. I'm going to write it as n is equal to 20. Okay. N is equal to 20 just means 20 data points, right? So we've taken the 20 data points and we've broken it into the first half. Okay, so this is your first half. Oops, let's switch the color here. This is your first half. This is your second half. Okay, so 50% of the data is below the median and 50% of the data is above the median. What about the first quartile or the lower quartile? 25% of the data is below the first quartile or the lower quartile, and 75% of the data is above the upper quartile. Okay, so this is, this is 50% below the median. Okay, and this is 50% of the data. Okay, so from here to here, we have 25% of the data is over here. Okay, so we're just basically looking at the number of data points. Okay, how many data points are below the first quartile? How many data points? We're not actually looking at the values. We're looking at the number of data points below that particular value. Okay, so 4.5 is the value, is the value coming from the data, whereas 25% is the number of data points. Okay, so that is the small distinction. So this is what is called a box plot or a box. It's called a box plot, or it's called a box and whisker plot. Okay, like a cat's whiskers, right? So it's just like, okay, like a cat's whiskers, right? So that's why it's called box and whisker plot, okay? Now, these two are the whiskers. So with this whiskers, right, this is always the end point of the whisker on the left side is the minimum. On the right side, the end point of the whisker is the maximum. Okay, so the maximum value is 9, and so this is at 9. Okay, right. Now, the minimum here is 2, right? The minimum here, let's use another color to maybe highlight. The minimum here is 2, and here it is also 2. Okay. Now, this place over here, right? This over here, right, is Q1 or the lower quartile, okay, which is 4.5. Okay, so that is 4.5. That is Q1 or the lower quartile. And the upper quartile is on the right side of the box. Okay, so that is Q3. And that is 7.5. Okay, so that is 7.5. And so you draw a box plot like this. Okay, so you take the lowest value or the minimum. Okay, and then here whatever is the lower quartile. First of all, you have to have an x-axis. Okay, you have to have a number line like an x-axis, which is evenly spaced. Only then the box plot makes sense. Okay, you cannot just randomly draw one like I'm drawing over here. Okay, you need an x-axis to actually draw it to scale. Right? And then so you draw Q1, then you draw Q2, and then you can draw a plot like this, and then you can say maximum. So that box plot tells us a whole bunch of things. It tells us that 50% of the data, 50% of the data is between 5.5. Okay, so the median was at 5.5. Okay, so that was the median. 50% of the data is above 5.5. Okay, 25% of the data is above 7.5. Okay, so 25%, that means if there were 20 values, 25%, that means 25% of 20 is 5. That means 5 values are above 7.5. Okay, so that's 1, 2, 3, 4, 5. Sorry, I'm counting here and you have no idea what I'm counting. These 5 values. Okay, so those 5 values are above 7.5. Okay, so that's what the box plot tells you. Okay, so you can make interpretations from box plots. If I have something like this, okay, and something like this, okay, then I can say, oh, look, I have 75% of the data is between this value 80 and 90 or something like that. And then you can say, oh, and here I have 70 and, okay, this is clearly not to scale. Let's make this 96, okay? This is 76, and maybe this is only 72, sorry, 68, and here I have, say, maybe 50, or maybe just make it 60. Okay, so something like this, right? So you can say, well, look, the spread is not even. Okay, you can see whether the spread is even or not. Okay, you can say, well, there's a huge spread of values. For the top 25% are spread out between 80 and 90, whereas the bottom 25% are all spread out between 60 and 68. There's a smaller spread on one side than on the other side. So there are things you can interpret based on how the box plot looks. Okay, so we'll leave that for now. On the interpretation, we come back and look at it at some other point. Okay, right now you should just know how to draw a box plot. Okay, so basically you need an x-axis which is to scale, and then you draw the minimum, the maximum, the lower quartile, the median, and the upper quartile. Okay, so that is all there is to drawing box plots. Okay, and just some small interpretation questions here. The length from the median to quartile 3 is longer, so this length, right? Oops, this length. Okay, this length is longer than the length from quarter 1 to the median. Okay, so this length. All right, so what does that mean? That means 25% of the data is between 4.5 and I think this was 5.5, right? So this is 5.5, this was 4.5. Okay, 25% of the data values are between 4.5 and 5.5, and another 25% of the data are between 5.5 and 7.5. Okay, so this is 25% of the data here, 25% of the data values, and this is another 25% of the data values are between 7.5 and 9, and 25% of the data values are between 2 and 4.5. Okay? Yeah, so that is how so what is the whisker above quarter 3 shorter than the whisker below quarter 1? What does this mean? That means there's a huge spread in the lower in the first 25% has a huge spread in values. That means the lowest 25% are between 2 and 4.5. Okay, let's try this together. What percent of the data is below the first quartile? Okay, so this is the first quartile or lower quartile. Okay, that would be 25% of the data is below the lower quartile. What percent of the data is below the third quartile or the upper quartile? Okay, what percent of the data is below the, so this is 25, this is another 25, that's another 25, so that would be 75% of the data is below the third quartile. 75% of the data is above which quartile? Above which quartile do we have 75% of the data? That's 25, 25, 25. So 75% of the data is above the lower quartile. Okay. What percent of the data is below the median? 50%. What percent of the data is between 4.5 and 5.5? Okay, so this is 4.5 and this is 5.5, and that's the median, right? Well, that should be 25%. So 25% of the data is between 4.5 and 5.5. What percentage of the data is between 5.5 and 7.5? That was Q3 was 7.5. So that's 25%. Okay. You can never say how many people were surveyed or how many data points are in the set by just looking at a box plot. But just looking at the box plot, it can only interpret what percentage of the data is distributed how. You can never say just by looking at a box plot, well, how many data points are there? Okay, it just gives you the spread in data. Here's another one. When you want to compare box plots, I'm going to skip this part because we are kind of running short on time. I have one here. We'll do this instead. These box and whisker plots represent distance traveled by school members of grade 8 and 9. What percentage of grade 8 students? You feel free to freeze the screen and answer this and then come back and have a look. The answers are on the next page, okay? Freeze the screen, answer this. I'm going to scroll down to the answers in a minute. And then you can come back and check your answers. Okay, I'm going to scroll to the answers. right? It looks like there's something that's not coinciding here. Okay. Which group does more traveling? And I said year 10. It cannot be year 10. It should be, you have to look at the range. Okay, so probably this one is at 14. This is at 1. Okay, so the range here. Okay, and for the other one, it is between 0 and 12. So the range here is 12. So I think that should be grade 9. I have no idea why I put year 10. That is grade 9. Okay. All right, that's all for today. I'm going to stop the recording. And if you have questions, please let me know. Try out your homework questions. Thanks. Bye-bye.